we're going to be creating an OSPF VLAN routing project. So here we're going to be creating 3 networks. Network 1, we're going to have 3 VLANs. They're going to be VLAN 10, 20, and 30. And in this network, we're going to be configuring InterVLAN routing using layer 3 switches. We're also going to have at least 2 hosts per VLAN in each network. Just going to be copying this over just to make it easier. Now for network 3, we're going to have 1 VLAN, and it's going to be VLAN 60. Also going to be configuring InterVLAN routing using a layer 3 switch, and we're going to have 2 hosts on this VLAN as well. In addition to the 3 networks, specifically we're going to configure OSPF between all of these 3 networks using area 0. We're going to be needing to connect all of the networks and the VLANs to one another, including all of the hosts or end devices. For OSPF routing, we're going to make sure that the routing tables are successfully filled out in each of the layer 3 switches. We're going to start creating the overall diagram of our network using these options as layer 3 switches. So here's switch 0, switch 1, and switch 2. Now, just to make it a little more easy to read, I'm going to rename each switch accordingly. Layer 3 switch 0, 1, and 2. To be able to see each of these individual networks a lot more clearly, we're just going to be drawing squares for each network, and also the VLANs themselves. Now for network 2, gonna make the color still green, just slightly different shade, just to keep things separate. Network 3, you're gonna using this more olive green, I think that's what you would call it. Let's just resize these. I think they're a little bit off. Alright, I think that's good right there. Let's just add names or labels to each of these individual networks. Now with this, we're going to easily be able to tell which network is which simply by this label, rather than having to compare, how many VLANs or hosts are in each individual network. So let's just create the boxes for the VLANs themselves. So network 1, we're going to make this blue. So this one is going to be VLAN 10. Here's the second VLAN, VLAN 20, VLAN 30, and you guys get the gist of it. I'm going to skip over. Okay, now that we got these all drawn out. Gonna start labeling each VLAN accordingly. VLAN 10, VLAN 20, VLAN 30, etc. So now it's time to add the individual hosts to each network, and as mentioned, it's going to be 2 hosts per VLAN. So I could use any of these devices, but specifically make it easier, just use these PCs. So PC 0 and 1 for VLAN 10, PC 2 and 3 for VLAN 20, and then boom. All PCs for each VLAN. So first things first, we're going to open up switch 0. And preferably I like to open all of them at the same time and see them side by side as well, just so that I can easily copy over the configuration settings to each device instead of completely filling out one switch at a time. Now let's just show all the interfaces for these switches. So we have fast Ethernet 0, 1 to 20 something. I'll be reserving 10 and above specifically for the host, and then 1 through 9 for any internal networking. Let's show the interfaces on switch 1, which will be the same thing, and also do that on switch 2. Now I'm just going to start creating the physical connections from each device. So for switch 0, I'm going to connect it to 0, 1 to 0, 1 on switch 1. And I'm also going to create the labels for each end so that I am aware from this diagram alone. This is going to make it so that anytime I'm configuring a specific interface, I'll easily be able to tell which one's which visually. So now connecting switch 0's second interface to switch 2's first interface and making the labels accordingly. Now connecting switch 2's second interface to switch 1's second interface as well. All of the hosts or end devices. Now on switch 0, I'm going to go ahead and take a look at the interfaces we have available again, and we're going to be using fast Ethernet 10 and up. So let's get the straight through cable connected to the only available Ethernet port on the PC, and then the 10th Ethernet port on the switch, and same thing for the second PC, but to the 11th port on the switch, and we're going to keep applying this for the remaining computers in this network. So now let's also connect the PCs in network 2 to the directly connected switch, applying the same idea. Now I'm going to be doing network 3, same thing. So let's go ahead and open up each switch, starting with switch 0 and looking at the interfaces, so we can see they're all showing up for the ones that are directly connected. We even see fast Ethernet 1 and 2 from the other 2 switches that we have connected through switch 0. So let's go ahead and just create the VLANs on switch 0. So we do VLAN 10. And let's go ahead and name that. So I'm going to name it VLAN 10 with no spaces. Now I'm going to show the VLAN brief so that we could see VLAN 10 was created and the name was saved as well to say VLAN 10 specifically. Now let's go ahead and create VLAN 20 and apply the same thing, naming it VLAN 20. And now let's show and see that it is showing correctly. So we have one more VLAN to do. It's going to be VLAN 30 on network 1. So now I'm going to exit the VLAN configuration specifically, and now we see all our 3 VLANs. So let's go set up the SVIs. So we're going to go to interface VLAN 10, and we can see interface VLAN 10 is created and the state is up. Now even though the state's set up, let's go make sure it's not a complete shutdown, so we're no shut. Now we're going to configure the network addresses for this switch. So we're going to do IP add, and I've created a list. Here we're doing IP add 192.168.10.1 and the subnet mask. Now the reason why it's a .1 is because this is going to be a virtual interface as if it was a router, so it's going to be treated as the VLAN gateway. So we'll go ahead and run the IP interface brief and see that VLAN 10 specifically has the 192.168.10.1 IP address. So we'll do the same thing for VLAN 20, interface VLAN 20, and we see this state is up, and we run no shut, and IP address 192.168.20.1, and then the subnet mask. Now let's do the same thing, interface VLAN 30, no shut, IP address 192.168.30.1, and then the subnet mask. Now let's see the IP interfaces. So now we see all 3 VLANs for network 1 and their IP address for each of those interfaces. So now let's configure the interfaces on the switch directly connected to the PCs 10 through 15. So interface range F0 10 to 11 I'm actually going to do since they're on VLAN 10. So I'm going to be running switch port, and then we'll be running the access VLAN 10. And this is going to apply for interfaces 10 and 11, which are connected to VLAN 10, of course. Now if we show the IP interfaces, we'll see that the actual protocol for VLAN 10 is up now because we have interfaces connected to that SVI. Now let's do the same thing, but for interfaces 12 and 13 for VLAN 20. Switch port access VLAN 20, and the state is up as well. Interface range 14 and 15 for VLAN 30, switch port access VLAN 30, state is up. Now let's just show the running configuration that we have currently. So we'll see interfaces 10 through 15 have the switch port, access VLAN, and the VLAN number accordingly. And if we keep scrolling down, we have VLAN 10, 20, and 30 configured as well. Now going back to our network, we're going to have to configure the PCs individually for a specific subnet. So PC0 will configure this IP address. So we're not using DHCP, so we're going to keep it static and configure it 192.168.10 for VLAN 10. And I'm also going to start it off with 10 as well, because that's the interface we're using for the switch itself. Subnet mask auto-filled, and the default gateway is going to be the IP address of the SVI, so 192.168.10.1. So now let's do the same thing for PC1, and this is going to be 192.168.10.11. subnet mask auto-filled, and the default gateway is the same. It's going to be a .10.1. Now, we can try pinging. We'll see that we ping 192.168.10.1. The default gateway is pinging correctly. Now let's ping the other PC, which is the .10 PC. And see, it's also pinging. And we'll be following the same concept for the other PCs. This is going to be 192.168.20.10, 192.168.20.1 for the default gateway, the SVI for VLAN 20. Doing the same thing on PC3, 192.168.20.11, and default gateway .20.1. PC4 and VLAN 30. Now PC5 on VLAN 30. I'm also going to create labels for each VLAN so that I know what subnet they're in. Now on network 2, let's go ahead and create the VLANs. So VLAN 40, name VLAN 40, and VLAN 50, name VLAN 50. Now let's go ahead and create interface VLAN 40 as SVI. Now let's run no shut and add the IP address 192.168.40.1. Go into interface VLAN 50 and no shut and add the IP address as well. Now we're going to exit and we're going to configure the interfaces 10 through 11. And these are going to be switch port access VLAN 40. And then interfaces 12 and 13. Switch port access VLAN 50. There we go. Now let's show the VLAN brief. And we can see for each VLAN we have the ports designated to each. We can also run IP interface brief and see both of those VLANs have IP addresses assigned to them and the protocols are up. Now let's configure the IP address of each of the PCs. And now we're going to do the same thing for VLAN 50 for both of these PCs. Now let's just go ahead and run a ping test to see if we can reach the other PC. So that's good. Let's try the gateway, and looks like this is good as well. Now just to show, we're going to see if we can ping the gateway on the other side of this switch, which we can. Now if we try pinging an actual PC on VLAN 40, it's not going to work because there's no routing. So now let's just go ahead and configure switch 2. Let's create the VLAN 60 and name it VLAN 60. Let's create the SVI, VLAN 60, no shut, and add the IP address. Now let's configure the interfaces 10 through 11. Switch access VLAN 60 and see the status is up. Now let's configure the IP address of each PC. Now let's see if we can ping the gateway. Looks like we're good. And now the other PC. And this one can ping as well on this VLAN. Now let's go ahead and set up labels for the internal routing. So between each of the switches, we'll 10.0 subnet, and for this one it's going to be a .10, and for this area it's going to be a .20 subnet, and then a .30 subnet. Now let's add some color just to visually see this internal routing. Now we're going to configure the internal interfaces of each switch for the internal routing. So what we're going to have to do is we're going to have to disable switch port on these and make them as trunks. So we see that the state was down and then now it's up. Now let's add IP address 10.0.10.1 and the subnet mask. And then we're going to do the same thing for the second internal interface of switch 0 for the 10.0.20 subnet. So this is going to be 10.0.20.1 for the IP, as you can see. Now when we take a look at the IP interface brief, we can see interfaces 1 and 0 are showing the IP addresses, and they're both showing status up and protocol up. Now we're going to do the same thing for switch 1 for the internal interfaces 1 and 2. Interface F01, no switch port, and then IP add 10.0.10.2, and then the subnet. Then we're going to go into interface F02, no switch port, and IP add 10.0.30.1. Now let's show the IP interfaces, and we can see interface 1 and 2 configured just like switch 0. All the other interfaces are also configured, including the switched interface. So we're going to go into switch 2 now and finally configure these internal interfaces. F01 is going to have an IP of 10.0.20.2. And interface F02 is going to have IP 10.0.30.2. All the IP interfaces look correctly configured on switch 2 as well. So now we're going to have to configure OSPF on these switches. So we'll open up configuration and try router OSPF 1, but we see there's no IP routing enabled. So we'll have to use IP for the global IP configuration subcommands And under IP we see routing to enable IP routing. So we'll just be typing in that command, IP routing, and looks like we're all set. So we try again, router OSPF1, and we're in the configuration for that now, for process 1 of OSPF. Now let's go ahead and configure the router ID. So this one's going to be 1.1.1.1 since you can't use 0.0.0.0, otherwise I would. Now we're going to go on switch 1, and we're going to go into configuration, and we're going to enable IP routing, and then we're going to go into router OSPF 1. Then we're going to create the router ID 2.2.2.2, and same process, going to do switch 2 now. Config T, IP routing, router OSPF 1, and router ID 3.3.3.3. So we're going to go back into switch 0, and we're going to be configuring the OSPF routing itself using area 0 in order to connect all of these networks and VLANs amongst each other. So we're going to do network, and we're going to put the network that we need to add into the routing table. So now if we look back onto our notepad and our list, let's just create a basis of what exactly we're going to configure within the OSPF. So we're going to have 192.168.10.0 and going into 192.168.60.0. And then 10.0.10.0 to 10.0.30.0. Now we're not going to be able to exactly input this into the OSPF configuration due to summarization, so we'll manually have to do 192.168.10.0 with a .255 wildcard, and also for the 20 subnet, etc., going up all the way to 60. This process is all going to be the same for the 10.0 subnet as well. And I'm also going to add the area 0 to all of these just to make it easier for us to read and input into the configuration. So now we have that information, we'll input network 192.168.10.0, and we're going to see we need the OSPF wildcard bits, so that's 0.0.0.255. And then we're going to need to put area, and we're going to be using zone 0. Now, in order to show this, I'm going to show IP protocol, and we can see the router ID, and then we can also see the routing network that we put into the OSPF configuration. So now let's go back into router OSPF1, and then we'll add the remaining networks as shown in that notepad earlier. 192.168.20.0 with a 255 wildcard for the last octet. And then we'll do it for the same 30 subnet. And so forth. Now after 60, we're going to be doing the 10.0 subnet areas, starting with the .10 network, and then the .20 network, and finally the .30 network. So now these should also show in the show IP protocol. We see the 192 networks, 10 through 60 subnets, or VLANs, and then also the 10.0 networks with the 10, 20, and 30 subnet. Now let's go on the switch number 1, with router ID 2.2.2.2, and we'll be following the same exact process. So network 192.168.10.0 and the wildcard for the last octet 255, area 0. Alright, so after a second, we're going to see the OSPF load and show full. So now the routing has been shared amongst the other switch. Using show IP protocol, we see the routes, and then we also see the gateway for the other switch, 1.1.1.1, when this one is 2.2.2.2. Finally, we'll do switch 2 configuration for OSPF for those networked routes. Network 192.168.10.0, 0.0.0.25, area 0, and repeating the process for the other networks such as the 20 VLAN, 30 VLAN, 40 VLAN, 50 VLAN, and 60 VLAN. We're going to do the same thing, but for the 10.0 networks. So at the 10.0.10, 10.0.20, and 30. Now that's done, we'll go ahead and show the IP routing protocol and see those network routes, but the gateways have not shown up yet, so OSPF is still loading, and there we go. So let's go ahead and show IP protocol again. And now we'll see those gateways listed underneath. Now let's go ahead and show the IP routing table. So we have all of the connected and the OSPF routes for switch 2. So the connected ones are 10.0.20 and 10.0.30, and those are the directly connected networks, as you can see here physically. And you can always use the codes right above to figure out what exactly is what. Now if we look at the diagram, we see the other network area is 192.168.60, and looking at the table, we see it there on the bottom showing it's connected, and under VLAN 60. Now the OSPF routes that we have in this table, we have 192.168.10 all the way up to .50. And then the other OSPF connection we have is 10.0.10.0, which is outside, not directly connected. Looking at the 192 OSPF routes, let's look at the 192.168.10. As we can see, it's outside of switch 2, including the .20, .30, .40, and .50 networks. So now let's go back into switch 0, and we see that it's been loaded on there as well. Show IP protocol, and we'll see all 3 total switches or gateways. Now let's show that IP routing table. We have the 3 directly connected networks, 192.168.10 up to 30, VLANs 10 through 30, and then also the 2 connected networks 10.0.10 and 10.0.20. We have an OSPF route 10.0.30, OSPF 192.168.40 up to 60, which are network 2's VLAN 40 and VLAN 50, and then network 3's VLAN 60. Now on switch 1, we see the OSPF loading, so let's go ahead and show the IP protocol. All 3 gateways are listed, and also the routes. Let's go ahead and show the IP routing table. We have connected network 10.0.10.0, 10.0.30.0, an OSPF connection 10.0.20, this side and not connected directly to switch 1. One thing you can note is that there's two interfaces going to 10.0.20, so I'm going through F01 to that 10.0.10.1 IP interface, fast interface 2, which goes to the 10.0.30.2 route. We have 3 OSPF routes, one for each VLAN 10, 20, and 30, 2 connected networks, VLAN 40 and 50, connected directly to switch 1, and an OSPF route to VLAN 60. Now let's go ahead and try to run a ping from PC0 from VLAN 10. Open up command prompt. Now let's go ahead and check the IP. We're on ipconfig 192.168.10.10 with the gateway 10.1. Let's just verify we can ping the gateway, which we are receiving packets for. Now let's try pinging the other PC in this VLAN. Oh, sorry, wrong one. .11. And we're receiving packets to the other PC in this VLAN as well. Now let's see if we can ping any PC from VLAN 20 from PC0. Gonna run ping 192.168.20.10. That's PC2. So far no packets being received. And there we go. Let's try running a tracer to that PC. So we put in that same IP address, and let's look at the hops. So it's coming from PC0, going to 192.168.10.1, which is on switch 0, and then 192.168.20.10, which is the IP address of PC2. Now let's try the same thing for VLAN 30. So do PC4. And there's the pings returning. If we run the tracer, it goes to 192.168.10.1, which is on switch 0. Then it goes directly to PC4. Let's try the same thing going from PC0 all the way to VLAN 40 and 50. We'll run a ping 192.168.40.10, which is PC6. Now there's the pings coming back. So we expect traffic going from PC0 to switch 0 to switch 1 and then PC6. Now let's run tracer. Now before we run this, let's try to get just an idea of what's supposed to happen. So it's going from VLAN 10, PC0, going into VLAN 40, PC6. Now the default gateway that PC0 is reaching is going to be from switch 0, 192.168.10.1. Once it reaches the default gateway on switch 0, it's gonna go out F01 interface, which is 10.0.10.1. This is now going to reach switch 1 on the F01 port, which is the next hop, and that IP is 10.0.10.2. From there, it's going to leave switch 1 via the SVI VLAN 40 interface. Let me fix this. The default gateway is also an SVI for VLAN 10. And finally, as soon as it leaves SVI VLAN 40, the destination is 192.168.40.10, which is PC6. So that's our expectation of the tracer, and we'll see here that that exactly matches. The 192.168.10.1 for the first hop, second hop 10.0.10.2, and the destination 192.168.40.10. Now let's try doing the same thing from PC0 VLAN 10 going to VLAN 60 PC10. When running the ping, we are getting replies back. Now let's run the tracer for that same IP address. Now let's compare the tracer. So we're going from PC0 to switch 0 through VLAN 10 SVI. Then from switch 0's F02 interface, going to F01 on switch 2, which is 10.0.20.2. And that's the second hop shown in the tracer. And finally reaching the destination device, PC10 192.168.60.10. Now I didn't test every single VLAN to another VLAN, but we've proven that you can communicate hosts from VLAN 10 to VLANs in network 2 and 3.